All right, chatting about our 13.1 homework. They give me some information and they say solve using the diagram given. So let me jot that down quick so I've got something to work with. So, what do I have? Well, let's see. I have an angle and a side. So, I've got, this is 37. I know my hypotenuse is 22. And it's my job to figure out these other three pieces to my triangle. Now, the easiest one should be to find angle B. Because what do I have to do to find angle B? No. Right, they're already giving me the right angle. I know this is 90.
Oh, yeah.
They gave me A, which is 37. So to find B, I just do 180 minus the sum of the other two angles, which would be 127, which gets me to, what, 53? Yep. So that should be the easiest part of this. So once I have that, now I have options to work with. I can use either the angles here, doesn't matter which route I go, so I'll just use the one that they gave me just in case I hadn't thought about this right away. So if the angle that I'm going to use for my purposes is this 37, I know what the hypotenuse is, so let's say I decide I want to do A first. So I'm like, okay, if I do A, what sides do I have? Well, I have opposite and hypotenuse, which is which of my trig functions? Sine. So I could do the sine of 37 equals opposite over hypotenuse. So to get A by itself, I'd multiply both sides by 22. And then I would say, okay, let's pull up the handy dandy calculator. Give out my advertisement for the flash. Okay. Pop it up just like that. And say, okay, again, make sure, look how blasted this thing. It's got to be in degree mode. I guess it was that way for a reason. So, mine seems to like resetting on its own because I've never putting it in radians. So yeah, you do want to check and just make sure. So then I will get out of there once I'm sure I am on degree. And then I just type it in. 22 times the sine of 37. And I get my A value, which is 13.2. Well, does it specifically? It doesn't specifically say whether to do tenths or not. I'm kind of surprised. So yeah, if you went to a whole number on that, that's okay. And then to get my next one, I just kind of play the same game. Except now I want B, which is my adjacent side if I'm using the 37. And I can still use the hypotenuse if I wanted to. So here, I could say, okay, now it's adjacent over hypotenuse, which would be the cosine 37 degrees, would be adjacent over hypotenuse, and I run that same process again. Multiply both sides by 22. Pop that into the calculator, and this time I'm going to cheat and look over there.
Cheater.
Yep. In this case, guilty. So that's how you would take care of the other pieces. The angle, I'll just use the fact I have a triangle, and the other ones I'm going to use my trig functions and the side they give me to work my way there. Now the other thing I had a feeling some of you would look at and say, whoa, what's he doing here? Is when you started to look at 18 and 20 for my answers and try to figure out, well, why do they look all different? Because I get the first one, but I don't get the second. So we're going to take a look at 18 for a second.
Oh, yeah, 'cause you can take them out.
Yeah, it's called simplifying or rationalizing your denominator. We've done that earlier this year, but it's another one of those things. It's been a while. So I want to make sure, because when you're looking in the book is going to have different answers than you might. And I want to make sure you know that your answers are basically the same thing. So if we were looking at 18 on page 772, we'll just take a quick look here to get, all right, and there's my theta. I'm going to have to figure out my adjacent side. We talked yesterday about how we can do that. A little Pythagorean theorem to work with here, because my x is this missing side that I have. So I work my way through this, and I get this funky decimal. And we really don't like decimals with this. It kind of messes everything up. So for the time being, I'm just going to have the square root of 153 as my adjacent. Like, ugh. So when I go to start building my trig functions, okay, I've got opposite over hypotenuse. Okay, that one came out nice. And since I have to come up with all 6 anyway, I'll go ahead and do its inverse cosecant right off the bat. It says evaluate the 6 trigonometric functions. So yeah, we need them all. That one will be coming, but when I'm doing sine, if this is my angle, sine is opposite.
No, like
Oh. Yeah, and we're gonna try to avoid that. For today, if you did, that's okay. But we're gonna try to avoid those because not only in the book but also in standardized testing, they'll always go to a radical on that instead. Yeah, so if you went to the decimal and you've got the decimal equivalent, that's absolutely okay for now. Just kind of see how this is gonna work here. Now I get to cosine, and I'm like, it's adjacent over hypotenuse. So again, if you wrote this, okay, that's fine for right now. But, you're like, oh, but. There's always got to be a but, Hardy. What are you doing? Can I break the 153 down? So we're going to go off into side work territory here.
Yes, you can.
Okay. 153 actually does break down to 9 and 17, because again, we talked about with your perfect squares, if I can break down a radical, I should. So if I take the square root of each of those, I get 3 times the square root of 17. So my cosine, as you'll see from my other answer over there, and an answer you'd get if you had one in the back of the book for this one, okay, that's what we're going to be shooting for. This isn't bad. This is better. Okay. Now, when it gets interesting is when you get to the inverse here. Because the inverse, well, I'm just going to flip it over. It's this.
No.
You know, what's the big deal with that?
The radicals on the bottom.
No radicals in the denominator. So, here's our next thing we're going to take on. If I take this 13 over 3 times the square root of 17, and I want to call what's rationalized the denominator, whatever that radical is in the denominator, we're going to multiply the numerator and denominator by that. Now you're going to pick up on a pattern here, and some of you are going to be able to start doing this without even thinking about it. So basically,
It's just going to be 17.
I've got 13 times the square root of 17. And then, right, the square roots basically just cancel each other. So square root of 17 times the square root of 17 is 17. Because if I were to multiply those together, why is it always got to open up where I want it to be? If I were to do the square root of 17 times the square root of 17, okay, I get 17 back, so it'd be the square root of 289 if I multiply the numbers underneath. So 3 times 17 is 51. So this, if I move my calculator out of the way, this is actually the simplified form of your secant. So whenever you see a radical in the denominator, just the radical, don't care about the 3 here, just multiply the numerator and denominator by it. So you're like, well, I'm just tacking it onto the top. Yeah, basically. We're going to simplify these and get them into their own. So it'll get better as you get more practice with it. Okay? And again, if you didn't do that on this one, and for most of you I expect wouldn't have, that's not a big deal. So finally,
Okay. Bless you. Tarantula.
oh, thank you.
Bless you.
So I've got opposite over adjacent. And they're like, oh, great. Now, you know that this
17.
turned into 3 square root of 17. So I'll get that here, but
Can't be on the bottom.
okay, I've got to fix that.
4 root 17 over 3.
Yeah, and you'll start to do this a lot quicker the more you start playing with it. So here, but again, I'm going to keep doing it and writing it out until I get comfortable with it. 4 square root of 17. Those multiply together and becomes just plain old 17. So 3 times 17 is 51. So my tangent is really 4. So kind of look at the old and then the new. You're like, so basically, Hardy, what you're telling me is this swings up to the top, and I just multiply those two numbers and just kind of ignore the radical. 3 times 17 is 51, up to the top. I've got it simplified. Exactly. So you're like, well, maybe, possibly, sort of. It's kind of weird, though. It is. It definitely is. So then you look at it and you go, okay,
3 root 17 over 4.
yeah, because if you think about cotangent,
It's just the opposite.
yeah, if I'd have done this originally, I'd have had the square root of 153 over 4. You're like, hey, there's no radical in the denominator. Sweet. But remember, this is really 3 square root of 17. So I didn't have to do anything fancy on this one because I didn't have a radical in the denominator. So it's just kind of getting your head wrapped around, yeah, I've got to get my trig functions down, okay.
Dang.
But if I get a radical in the denominator, just multiply the numerator and denominator by it and go about your business.
Oh, it's,
But again, you'll get to a point
you just
like you do here where you see this and you're like, whoop, swing that up. Whoop, 3 times 17 is 51, I'm done. We'll get you to that point. It's just going to take playing with them a few times, and we'll keep kind of messing with them and be like, and then it'll be like, oh, okay, that wasn't so bad. This one got a little nastier because that radical happened to break down.
This packet sucks. Yeah, we have to answer with complete sentences.
No, I'm not going to make you answer with complete sentences.
That's what it says right at the time.
There's 2 types of special triangles where, yes, I could figure these out using my regular trig functions, but you want to be able to have some flexibility or to be able to do things faster. So we're going to take some time to go over this whole 45, 45, 90, and 30, 60, 90 triangles, just again to give you that extra bit of strength, because if some of you are moving on next year to college algebra / trig, this is going to be one of those expected things that you know. So 45, 45, 90. Now let me mention again here, the odds that we are going to be doing are the notes. Okay. The evens are going to be the homework. On top of this, let me also say that tomorrow we are going to end up having some workday time in here because I'm going to take my sweet time with this. So don't panic if things like, just stay with me. Okay, a 45, 45, 90 triangle.
I forgot to say.
Okay, has base sides, or a base ratio relationship that they have. And here's how it works. Your legs are both going to be x. They're both going to be the same in length. Because if their angles are the same, the sides have to be the same. And then your hypotenuse is always going to be x square root of 2. So like if my side is 5, my hypotenuse is 5 square root of 2. Okay, if my leg's 20, my hypotenuse is 20 square root of 2. Okay, seems like a straightforward enough thing to deal with. Because you look at, for instance, number 1, and I see that my x value, okay, my leg value is 2. So my hypotenuse, 2 square root of 2.
It doesn't sum up.
Nope, that doesn't break down anymore, so that's good. Okay. Now, you look at one, let's say 3. Now again, this shouldn't be bad. Because if you look at this, think of it like, okay, this is x square root of 2. So what does x equal? 11, because it's just the number in front of my radical. So my legs are each 11. What's that? Oh, h looks too much like 11? Okay. Now, 5 is where life starts getting a little more complicated. Because here, well, it's 14. Well, wait a minute, that doesn't even have a square root in it. What's the deal here? So we're going to have to play an equation here. So 14 is equal to this x squared root of 2. Now, we're not going to have to do this every time. We'll get to the hang of this, but again, it's going to take some practice. If I want to solve for x, what do I need to do? Okay, I need to divide it by the square root of 2. They're like, oh, crap. But you can't, because again, we remember, oh yeah, I can't have a square root in the denominator. Shoot. So remember, yeah, so remember the trick that's involved here. Okay, I'm going to start kind of stressing this. Let me put this over here. If I have 14 over the square root of 2, swing the radical up to the top and get rid of it down below. So I lose the radical, but I just add that to the top. But this one, can I do anything else to this one?
Divide by 2.
Yeah, I can simplify that stuff that's not underneath the radical. So 7 square root of 2. That is what my two sides are going to end up being. Okay? But if you can remember when you're dealing with a radical in the denominator, that all you're basically doing is putting it on the top and losing the radical on the bottom, the simplifying thing isn't going to take you a long time. It's not going to be a big, drawn-out process. Sometimes this will simplify like it did here, and sometimes it won't. But again, nothing that's too big and terrible and awful, and things like that. Okay. 7, I get into the same situation. Now, I'm going to see if some of you figure out a pattern here in a minute, but we're just going to...
Boom, got him.
Uh-huh.
Smack.
Well, that's a really good guess, because here's what you'll find out. If you start doing the work here, and you're like, okay, so 10 is x squared root of 2. Now, I got to divide by the square root of 2. Yeah, Hardy. And so then I'm like, okay, so if I do that little trick we were talking about before, and I say, okay, I've got 10 over the square root of 2, swing the radical to the top, and just lose the radical down below, and simplify it, you're like, okay, that's not bad. But you know what's even cooler about it? I think I can get away with not even having to do this. Because now let's go into a comparison between 5 and 7. 14 divided by 2 is 7, and I just pop the radical on it. 10 divided by 2 is 5. Just pop the radical on it. Okay? You can do all the work if you forget that sometime or something, but if not, it's kind of a nice thing. It's like, oh, there's a pattern here. I can just hack this in half and slap the radical on. That absolutely works. We like finding ways to make this shorter and easier. But again, it's just kind of putting in the time and getting in the practice. And then we get to an easy one again.
Question.
Hopefully answer.
For the bottom ones,
We're almost there.
to solve them.
Yes, we have to solve them for x when we get there.
But like actually
Yeah.
get them out of random.
Okay, use the trick on 11. What are my legs each going to be? 8 square root of 2.
What if
Nice.
it's like an odd number, like number 4? I just messed up and
In
saw it.
that case, then you're going to kind of have to work your way through because you'd end up with 5 square root of 2 over 2. Because if you think about it, if you divide 5 in half, it's just 5 halves. So it still works, it's just you end up with a fraction.
All right, it was a good question.
It was a good question. So when we get down to the bottom then, find the value of x. Now it's not like the other one where I got to find everything. But if I know this leg's 8, I also know this one's 8. Bless you. What's the hypotenuse going to be?
Just joking. 8 over square root of 2.
8 square root of 2. Because again, the pattern is x, x, x square root of 2. Ooh, we get to do double ones here soon. We'll see about that. Okay, x. Don't let the idea that it's a square mess you up.
All the ones are 18.
We're looking at a triangle here still. And then right, that's my hypotenuse.
I thought you said we had to solve it.
18 square root of 2. Huh?
I asked you if we had to solve it. Yes.
Well, we just know this. There's no solving involved with this.
Yes, you're right.
What?
I solved all of them.
I'm just saying. All right, so these are each my x's. 5. I have the hypotenuse for 5.
4 square root of 2.
Nice. Cut it in half, slap the radical on it. Whoa. Earthquake. Okay. So again, it's not awful. It's not bad. Kind of happy about it. So, let's flip over. Because there's one more special triangle to play with. Don't go flying along so much thinking, I got to get all the homework done right now, that you miss this next part. 30, 60, 90, there's a little more thinking. All right. So, we have 30, 60, 90. Okay, here's how it works. The shortest side will always be opposite the shortest angle. So here's my 30. So my side opposite 30, my short side, is x. My long leg opposite my 60 is x square root of 3. And then my hypotenuse is going to be 2x. So the short side is x. My in the middle is x square root of 3. And my hypotenuse is 2x. So the thing that gets interesting about that is when you start to work with the triangles on this, and this is just me, I'd go ahead, I'd put my other angle in if they don't give it to me, because it's going to help me think about this for a minute. Okay. My 30, this 8 that I have, okay, that's my x, because that's always my short side. So if I know that's x, that should make the other parts easy. Because my long leg is just whatever x is, 8 times the square root of 3. So if I ever can figure out what that short side is, it makes everything else just come together. Y is just 2 times x. 2 times 8 is 16. But a lot of it comes back to finding that one value. So here, 30, good, they give me my short side again. Okay, that's what x is. So if x is 1/2, what's my long leg going to equal? 1/2 square root of 3, or you could also write that as square root of 3 over 2. Either one would work. What's that? Yep. And then our x value is just 2x. It's 2 times 1/2, which is 1. Why did I just do number 2? I don't know. I should skip number 3 now. No, I won't.
Y is 14 with
Okay. Yeah, here we're starting to get into this habit thinking we're going to be given the short side every time, but we're not. So here, if that's my x, my long side or my long leg's over here. So pop the square root of 3 on there. And my hypotenuse is always double my short leg. Finally, when we get to 5, we get to do something different. So here, now, this is interesting. This is my x square root of 3 side. So, all right, x square root of 3 is going to be equal my 6. They're equivalent. So we already know the drill on this. I'm going to divide by the square root of 3, but I know how this works. Swing that to the top, so 6 square root of 3 over 3. Ooh, I can reduce this time though. So it's 2 square root of 3. You're like, well, what's 2 square root of 3? X is. So this is 2 square root of 3.
Does that mean that y is just 6 root 3?
Well, y is double this. 4 square root of 3. Okay, so there will be a little bit of algebra occasionally if you're given either, well, basically it's only going to be when you're given the long leg. If they give me the hypotenuse, that's not bad. Oh, speaking of, number 7. Which side do I have in number 7? I have the hypotenuse, which is 2x. So if I divide by 2, that gets me my short leg, or my side that's opposite my 30. And if I have the short leg, that's great, because it makes this simple. I take that x value and slap a square root of 3 on it. Okay, so if you're given the hypotenuse, you're always going to want to do that short side first, because it's just divide by 2, and I can build easy that way. All right, let's see here. Eee. All right, 30, 60, 90. What have I got here? I got the hypotenuse again. So what's my x going to be since that's my short side? 9, because it's going to be half. If 18 is 2x, it's going to be 9. And what's my long leg going to be? 9 square root of 3.
I have a question.
Sure.
Wait, never mind.
Okay. All right, 11. Because I blended a couple from the other side in. See if you're paying attention. So actually, 11's going to be eerily similar to the last couple we've done, because I've got the hypotenuse again. So again, just keep your sides straight. The one that's opposite 30, which is my x in this case, cut her in half. And once you've got that, you've got the other piece. Okay? So, your task.
It's complete.
Knock the rest of this one out.
Done.
And then, once you've knocked the rest of this one out, if you didn't notice what I'd written up on the board, you will probably want to notice now. When you get to the trig apps pack, okay, you do not, ooh, I probably should put this on video if administration sees it, they won't be happy with me. Set it up and solve it, okay? On this one, the evens are homework. The odds are extra credit, okay? When you come in tomorrow, we'll go over things, we'll see if there's questions on stuff, we'll get things set with that, and then we're going to get a little bit of time in there to work, but we're going to do a small start to the next piece of this. So we'll kind of keep inching ahead. I think that's about it for now.